Great, thanks very much for the invitation. I think I should have probably gone before Sam. I'm going to do a very broader kind of talk, I guess, whereas Sam kind of very specifically talks about some of the technical issues within some of these dashboards. And I'm really going to start by talking about, is some of this smart city technology data fit for purpose to be able to create new official statistics, and some of the issues in relation to that. This is going to get a bit awkward because this screen is not showing me what you're seeing at all. Okay, so I'm probably going to be facing this way for a lot of it because it's the only way I can see the slides. Okay. So this is a project funded by Science Foundation Ireland. It works over 4 years, has a team of about 10 people, and we have 4 work packages. So one of them is around data access, data quality and standards. One is around multimodal interaction. So we're not just creating dashboards that work on a screen like this, we're creating them that work in 3D, so they work in AR, they work in VR, they work on having a 3D printed model where you project the data onto the printed model. They work on mobile phones, not just on a laptop or a desktop, and so on. We have a whole area working around data analytics and modeling. So not just visualizing the data, but what insight can you extract out of the data, so what kind of statistics and modeling. Nearly all of these dashboards just show you the data. They don't allow you to do any statistical analysis on the data. They don't allow you to pull different data sets into conversation with each other or do any analytics on them. And then we have a whole series of work around data literacy and outreach. So we know from our user requirements analysis and our user evaluation analysis that the vast majority of people in the city just do not know how to interpret dashboards or to make sense of them or to pull information out. And we certainly know from our Dublin dashboard that exists at the minute that it's just simply too high level and it loses most people almost straight away. So we've been doing a lot of work on how can you put the data in a format that ordinary everyday people can make sense of and understand what's happening in the city. It's an open science, open source, open data project, so all of the code and everything will go up on GitHub at the end of the project. Any other city will be able to download it, build their own dashboards out of it. All of the data that goes in has to be open data, and and so it has to be, the idea also is low cost, low maintenance, informs best practice, specifies framework, specifies guidelines, and so on. As Sam's already said, a lot of these dashboards, save for some of the spatial temporal display of the data, we know that there's no standardization at all, and almost everybody is displaying similar data in different ways. So it's not like displaying a map where you know there's going to be a scale or a north arrow and a legend and a whatever. Everything looks different. We're using a lighthouse follower model, so we're building it for Dublin and then replicating for Cork. And we have the 4 local authorities in Dublin and the 2 local authorities in Cork. The Central Statistics Office and Ordnance Survey Ireland are our partners, just so you know. Okay, so move on to smart city technology, right? This is a diverse set of technologies that are used to manage the city. There's a whole suite of them. So from across government, with things like online transactions, city operating systems, performance management systems, into security and emergency services, so things like centralized control rooms, digital surveillance, predictive policing, coordinated emergency response, into transport with intelligent transport systems, integrated ticketing, smart travel cards, real-time passenger information, smart parking, logistics management, into energy with smart grids, smart meters, energy usage apps, smart lighting, waste, you might have compactor bins, dynamic routing, collecting, environment, various kinds of sensor networks, buildings, you have building management systems, sensor networks within the buildings, homes, you'd have smart meters, app-controlled smart appliances, and in the civic domain, various kinds of open apps, open data, volunteer data hacks, and so on. Okay, so there's a kind of a wide suite of different technologies, nearly all of them all of them producing and using data, but a lot of them actually producing data. If they're not producing the raw data, then they're creating derived data from the system. So we have a whole series of urban big data being produced. So for me, what I mean by that is it's data that's produced in real time. It has high velocity. It's exhaustive, so it's everything within a domain. So an automatic number plate recognition camera is capturing every single car on the road network. It's not capturing a sample of 1 in every 10 or 1 in every 50. It's every single car. The people counters are capturing every person walking past that bin or lamppost or camera, not every 10th person, and so on. So they kind of tend to be exhaustive data sets, and they're granular. They're at the level of the individual. So it's an individual person, individual object, individual vehicle, individual territory, individual whatever it is. So it's very granular data. And it comes in different forms. So it can be directed, so it's still got a human in or on the loop, so a person pointing the camera, directing the camera, moving the camera around, or mediating the experience, as in public admin records. Or it could be automated, so automated forms of surveillance, various kinds of digital devices, your smartphone's the classic example. You know, this phone's telling Vodafone where I am every 4 minutes, and all the other apps that I've got location turned on for. Sensors, actuators, transponders, meters make up the Internet of Things, various kinds of interactions and transactions I might do through the apps or through programs, and then kind of data that we volunteer ourselves, whether that's through things like social media, through wearables, through crowdsourcing, through citizen science, and so on. So there's a whole series of different data, and that data is effectively being used for operational reasons. So this is, as you all know, this is not data that's been created with official statistics in mind. This is data that's been created to help run particular systems and manage things on a more here and now basis. And some of that data is being integrated together across single domains. So within a port environment, you might be pulling data from the boats, from the cargo containers, from cameras, from pollution sensors, from the vehicles moving and that data gets pulled into a centralized control room and is used to manage what's going on in the domain. And increasingly, that's being pulled together through these what's called city operating systems. And there's a number of companies who have put together various types of city operating systems. So there's IBM's Intelligent Operating Center, Abotica's City Operating System, Living Planet's Urban Operating System, Microsoft City Next, and a few weeks ago, Huawei suggested that they were, this was their kind of schematic for how they were imagining running cities by effectively pulling the data in, so breaking down the silos between different city departments, pulling all the data in. So in the same way I can use this computer to use PowerPoint and Word and Excel and so on, I could use this computer to look at transport, to look at energy, to look at infrastructure, to look at whatever it is, education, health within my city. That's the idea of these city operating systems. And this data is increasingly being pulled together into these control rooms. So these are 4 different control rooms. Probably the most famous one is the top left here. It's the Rio control room. It's got 400 workers in there on a 24/7 basis. It's pulling in data from real-time data from 32 city agencies and 12 other companies, utility transport companies, and it's trying to manage the city in real time from this single kind of basis. Transport data, weather data, environment data, health emergency service data, policing data, and so on, streaming in to that center. The top right is just outside Tokyo. It's a district in Tokyo, and you can see some of the dashboard analytics being used here. This is a traffic management system in Dublin. And I can't remember where that one is. I normally get a picture of wherever I'm going, and I forgot to do it. But I guarantee you there will be a control room here. In fact, there's probably several. There's seven or 8 of these rooms in Dublin doing different things, whether it's energy, transport, telecoms, whatever it is. And producing a whole series of very rich data about what's happening. And increasingly, some of that data is going out into these city dashboards. So it's porting out into either public-facing dashboards or dashboards that are just used internally, maybe within the mayor's office or within the city manager's office, and so on. So this is what we're interested in, is how can we take some of that data. And one of our questions in work package 1 and the work that we're doing with the Central Statistics Office is considering, can we use some of this data to create new official statistics? So that's one of our kind of key questions. So this is the real-time information that we're currently getting on the right-hand side. So we have access to these data. The nice thing about Dublin actually is all of this data is open data with the exception of the location of the buses. So we have that as a private university project. We have a sample of that, but it's not on the dashboard. All the rest of it's on the dashboard in some form. So we have bike share. We know how many bikes are in the stands. We know how many stands are vacant. We know how many spaces are in the car parks. We know what the road speeds are on the road segments. We know what the road temperature is. We know the real-time passenger information, so the countdown signs you see at all the bus stops and train stops and so on, we have that information. We know the location of all the boats in the harbour. We know where the trains are. We know where all the planes above us are. We have a feed from the traffic cameras. We have a 5-minute time slice on the traffic cameras. We have the sound levels, the pollution levels, bather water quality levels, the water level in the river, have tidal levels and wave and height intervals, and then we have some weather information and so on. And what we're interested in are kind of questions around the suitability of that data for making sense of the city and various issues around them. So they might be useful for managing in the here and now, but are they useful for official statistics is one of our questions. And so we're kind of doing a very broad evaluation of urban big data, which includes smart statistics, and we're really thinking this through from a social science perspective, as well as a kind of more technical geocomputational perspective. So we're considering issues around epistemology, around scope and access, around veracity and validity, around usability and literacy, around use and utility, what can you actually do with the data, and then around ethical issues, around privacy, around confidentiality, around all kinds of stuff around ethics of care, social justice, citizenship, kind of broader moral philosophy, normative ethics around what you do with this data. So just to go think through the epistemology. So the power and the utility of smart urban data is their seeming ability to be able to show us in detail and often real time what's happening in cities, to translate the messiness and complexities of cities into kind of rational, detailed, ordered forms of knowledge, to show the city as it actually is in objective, trustworthy, factual data, and to provide fine-grained time series data at specific locations. So it adopts a realist epistemology. It kind of frames the data in very neutral, value-free, objective, essential ways. So essential is in it represents what it claims to represent, and when you analyze it, it similarly reveals the objective truth about the city. But from a critical data perspective, there's all kinds of issues with those kinds of assumptions. In the sense that the data is not neutral, commonsensical, it constitutes a socio-technical assemblage. All kinds of decisions have been made about how to set up these systems, about what values and so on are embedded in them. They tend to take very complicated systems and reduce them down to individual variables. So it kind of atomizes what's going on in the city, and it decontextualizes the city from its history, from its governance, from its politics, from its culture. You just get the data, right? But you don't get it in the situation of knowing what's happening. It's not to say they don't have utility. I think you have to kind of think very critically about what it's showing. So this is the notion. So what we've been trying to do is pull apart some of this data by pulling apart its socio-technical assemblage. So, for example, I've embedded 2 ethnographers in the traffic control room to look at the ways in which the data in there is being produced, how it's being used, how it's being managed, to actually understand the politics, the institutional arrangements around that data. I've had somebody do the same with the real-time passenger information, place them in the room, interview the people using that data, find out what the ins and outs are around that system. So there's an issue in the system in Dublin around the Irish language, taking up a field in the database where it shouldn't be there, and it causes all knock-on issues. It creates ghost buses, so you can be stood at a bus stop, it goes 5 minutes, 4 minutes, 2 minutes, no bus turns up, next bus 20 minutes, like where's the bus? You know, and it's an artifact of how the database has been set up and have been managed. Okay. So we're kind of picking apart this and understanding how this data is actually produced and the politics and so on invested in that data. We're interested in the scope and the access of the data. So it's generally quantitative data. It's It's what can be tracked over time and space. The qualitative data is typically just limited to social media. There's all kinds of problems of representativeness. Only 4% of people over the age of 65 are on Twitter, for example. It's really not representative data of a population. There's an enormous amount of cities, enormous amount of information about cities that's not in scope. So within these dashboards, it's mainly transport and environment. Any other data is actually coming from official statistics. So all of our health, education data and so on is actually coming from the Central Statistics Office itself. And it tends to be quarterly, half-yearly or yearly data. It's certainly not in anywhere near real-time data. There's all kinds of scale and coverage issues. So where are the sensors? What areas are they in? What's kind of going on there? And what gets covered? All kinds of issues of access in terms of levels of openness across administrations, companies, places, lots of issues around privacy and legal issues, lots of issues around data security and protection, and lots of issues around ownership and payment, as you all know, as you've been negotiating to get access to some of the data. And even when you do get data, there's loads of issues around data measurement and data standards, data formats and media. We still get given data in PDFs, for example, from different state agencies. We still have issues around APIs and so on with some of the real-time feeds. Loads of issues around metadata and modes of sharing. And a lot of this stuff is black box, so you can't get in and look under the hood and find out what's actually going on, which is partly what we were trying to do with the unpacking that assemblage, was to try and get in under the hood to find out what was going on. You just have to accept the data at face value, basically. And then loads of issues around veracity and validity, so data quality and provenance. And for much of the data in the Dublin dashboard, we can't tell you its quality, its provenance. We don't know its error, we don't know its calibration, we don't know its precision, we don't know its fidelity. We pretty much know nothing. You just have to trust us that it's right. And we have to trust the data provider that it's right. You know, and they actually, we've asked them, and they don't know those things either. So that's one of the reasons why they can't tell us, is they don't know. Okay, so there's loads of issues around fit for purpose. So direct measurement versus proxies and inference, and then the representativeness of the proxies. I think that came out yesterday for me in the Google the satellite maps for trying to measure economic performance. So I think there's large issues there around representativeness of the proxies. There's human error biases, all kinds of processes of abstraction, representation, generalization, calibration, noise, and so on. The various different ways in which the technical instruments and the various specifications of them make a difference. So if you've got different cities using different sensors, are they actually measuring the same thing? Or do they have the same kind of parameters around them, levels of quality around them? Are they directly benchmarkable or not? Or even within a city? There's reliability and consistency across data production and handling, and changes over time. So we'll often find APIs changing. We'll often find how a company is measuring something. They change the instrument, or they change the measurement method, or whatever else. So again, there's issues around. These are not stable platforms that are controlled by like a state agency that can mandate that. Like, companies and cities will change their technologies and the ways that they do things as and when they need to, basically. So that creates issues. As I've already said, the data is published without metadata. All kinds of issues around validity, the analysis, interpretation, and then there's all kinds of issues there around ecological fallacies. So the maps on the right, for example, is the classic modifiable error or unit problem. That is exactly the same data, just displayed at 3 different scales. And how I'd interpret the data and my conclusions might vary based on which level of the analysis I've done that. And we've done the same kind of analysis with the real-time data, and you actually get a temporal ecological fallacy as well. So whether you're sampling or aggregating the data over 10 seconds, 1 minute, 5 minutes, 10 minutes, an hour, a day, a month, whatever, you actually would get a different temporal pattern come out of the data. So we've been kind of looking at these kind of temporal ecological fallacy issues. I'll skip over that side. And so just to conclude, so urban big data is proliferating, as are the various ways to make sense and act on those data. The significant issues around epistemology, around scope and access, and around veracity and validity. There's also around data literacy, usability, ethics, and so on. And we think there needs to be a lot more work done on trying to resolve those if smart city technologies are going to be used for new official statistics. We do think they can be used to make sense of the city and so on, but whether you want to make them official statistics is a different matter. I think there's real questions there around representativeness, around trust, around validity, around veracity, around stability and reliability, and all of those are open at the minute, and a lot more work needs to happen around them before we'll be able to move from kind of pilots and experimenting to any kind of mainstreaming. I'd be very cautious about them at the minute on the work that we're doing, looking at them on that basis. So there's a lot of issues, and they're not just technical. They're actually political, and they're institutional, and they're legal, and they're a lot more thorny to deal with than just trying to resolve some of the technical issues, although a lot of the technical issues are difficult enough in and of themselves. I'll end there. Thanks.
Thank you very much.